Let me show you something that happens in almost every automation project. You have 10 test files. Each one starts with the same setup code. Create a browser. Log in. Navigate to the dashboard. Then at the end, close the browser. Log out. Clean up. 40 lines of boilerplate. In every single file. Now someone changes the login flow. Maybe the password field has a new ID. Or the URL changed. Or authentication now requires a two-step process. You update it in one file. Then another. Then you realize you missed 3 more. A bug slips through because one file still had the old setup. This is not a testing problem. This is a code organization problem. And the fix has existed in pytest since the beginning. It is called a fixture. And once you understand it, you will never go back. A fixture is a function that pytest runs before your test, sets something up, hands it to your test, and optionally tears it down when the test is done. No duplication. No copy-paste. One definition. Used everywhere. In this episode we are going to break down fixtures from scratch. Show you how conftest.py lets you share them across your entire project. And cover fixture scope so you control exactly when setup and teardown happen. By the end, your test suite will be cleaner, faster, and a lot easier to maintain. Let us get into it. So what exactly is a fixture in pytest? At its core, a fixture is just a function decorated with the @pytest.fixture decorator. When a test function declares a parameter with the same name as a fixture, pytest automatically calls that fixture and passes its return value to the test. Here is the simplest possible example. You define a function called sampleUser, decorated with @pytest.fixture. Inside, you return a dictionary with a name and an email. Then in your test function, you declare a parameter also called sampleUser. Pytest sees that, finds the matching fixture, runs it, and passes the result in. Your test never has to create the user itself. It just receives it, ready to use. Now here is where it gets powerful. Fixtures can do setup and teardown. You use a yield statement instead of return. Everything before yield is setup. Everything after is teardown. So if your fixture opens a database connection before yield and closes it after yield, pytest guarantees that connection is closed, even if your test fails or throws an exception. That is a huge deal. With regular setup and teardown in class-based tests, an exception in the test could skip your teardown entirely. With yield fixtures, cleanup always runs. Fixtures can also depend on other fixtures. Just declare them as parameters. A user fixture can depend on a database fixture. A logged-in page fixture can depend on both a browser fixture and a user fixture. Pytest resolves all of it automatically. You just described what you need. Now here is the question. If a fixture is just a function in a test file, how do you share it across multiple test files? That is exactly what conftest.py is for. Conftest.py is a special file that pytest discovers automatically. Any fixture defined in conftest.py is available to every test, in the same directory and every subdirectory beneath it. No import required. Pytest handles the discovery. Here is how you would structure a real project. At the root of your tests folder, you create conftest.py. In it you define your browser fixture, your base URL fixture, your authenticated session fixture, anything that multiple test files need. Then in your individual test files, you just declare those fixture names as parameters. That is it. Pytest finds conftest, finds the fixture, wires it up. You can also have multiple conftest.py files at different levels. One at the root for project-wide fixtures. One inside a specific module folder for fixtures that only that module needs. Pytest respects the hierarchy. A test in the API folder can use fixtures from both the root conftest and the API level conftest. This is how professional automation frameworks are structured. Not one giant file with everything in it, but layered conftest files that give you the right fixtures in the right place. When you set it up this way, adding a new test file means writing test logic, not rewriting setup code. The infrastructure is already there. Let us look at a real before and after with code. Before Fixtures, a typical Selenium test might look like this. Inside the test function, you create a Chrome driver. Set an implicit wait, navigate to the login page. Find the username field, type your credentials. Find the password field, type the password, click submit. Wait for the dashboard, run your assertion, then call driver.quit. Every test that needs a logged-in browser repeats all of that. Now here is the same thing with Fixtures. In conftest.py you define a fixture called authenticated browser. Inside, you create the driver, log in, yield the driver to the test, then quit. In your test file, your test function declares authenticated browser as a parameter. The test body is now just 2 lines. Navigate to the page you want to test. Assert the thing you care about. The setup and teardown live exactly once in conftest. Now imagine you have 30 tests that need a logged-in browser. With the old approach, changing the login flow means updating 30 tests. With Fixtures, you change one function. All 30 tests get the fix automatically. And here is another thing this makes possible: composition. You can build a page fixture that depends on authenticated browser. That page fixture navigates to a specific section of the app and returns the page object. Now your test just receives a ready-to-use page. Not a browser. Not a logged-in session. The exact page it needs to interact with. No setup code at all. One of the most important concepts in pytest fixtures is scope. Scope controls how often a fixture is created and destroyed. There are 4 scope levels: function, class, module, and session. Function scope is the default. The fixture runs before each test and tears down after. If you have 10 tests that use a browser fixture with function scope, pytest creates and destroys 10 separate browser instances. That is clean. Every test gets a fresh state. But it can be slow. Class scope runs the fixture once for all tests in a class. Module scope runs it once for all tests in a file. Session scope runs it once for the entire test run. So when do you use session scope? Use it for expensive setup that does not leave side effects. A database connection pool. A read-only API client. A browser session. Where every test navigates independently without changing shared state. Use function scope when tests modify data or state. Each test should start clean if it is going to change things. Here is a common pattern. A database fixture at session scope creates the connection once. A transaction fixture at function scope wraps each test in a transaction and rolls it back afterward. That way your tests run against a real database connection, which is fast to reuse. But each test automatically undoes its changes, which keeps them independent. Getting scope right is the difference between a test suite that runs in 2 minutes and one that takes 20. Start with function scope, profile your slowdowns, and upgrade to a wider scope only when the fixture has no side effects. Here is what you should take away from this episode. Fixtures are the foundation of clean, maintainable automation. They eliminate setup duplication, guarantee teardown even when tests fail, and let you compose complex test environments from simple building blocks. Conftest.py is how you share fixtures across files without imports. Scope is how you control the cost. Function scope for stateful setup. Session scope for expensive, side effect-free resources. If your test files currently have setup code in them, that is your next task. Move that code into a fixture. Put the fixture in conftest.py. Watch your tests shrink to just the logic that matters. That is what a professional automation framework looks like. The test says what it is testing. The fixtures handle everything else. In the next episode, we are going into mocking and patching. How to test code that depends on an API you do not control. A database that is not available in your CI environment. Or a third-party service that costs money every time you call it. You are going to learn how to replace all of it with controlled test doubles. So your tests run anywhere, anytime, without external dependencies. If this episode helped you level up, subscribe to QA Career Lab. New episodes drop daily. See you in the next one.